Visit Chandra's beautiful universe, Sagittarius A star. As the Event Horizon Telescope, known as the EHT, collected data for its remarkable new image of the Milky Way's supermassive black hole, a legion of other telescopes, including 3 NASA X-ray observatories in space, was also watching. Astronomers are using these observations to learn more about how the black hole in the center of the Milky Way galaxy, known as Sagittarius A star, Sag A star for short, interacts with and feeds off its environment some 27,000 light-years from Earth. While the EHT observed Sag A star in April 2017 to make the new image, scientists in the collaboration also peered at the same black hole with facilities that detect different wavelengths of light. In this multi-wavelength observing campaign, they assembled X-ray data from NASA's Chandra X-ray Observatory, Nuclear Spectroscopic Telescope, or NuSTAR, and the Neil Gehrels Swift Observatory. Telescopes outside of NASA involved included the East Asian Very Long Baseline Interferometer, or VLBI network, that observed radio emission. There was also the global 3mm VLBI array, along with infrared data from the European Southern Observatory's Very Large Telescope in Chile. One important goal of this so-called multi-wavelength observing campaign was to catch X-ray flares, which are thought to be driven by magnetic processes similar to those seen on the Sun, but can be tens of millions of times more powerful. These flares occur approximately daily within the area of sky observed by the EHT, a region slightly larger than the event horizon of Sag A star, the point of no return for matter falling inward. Another goal was to gain a critical glimpse of what is happening on larger scales. While the EHT result shows striking similarities between Sag A star and the previous black hole it imaged, M87, the wider picture is much more complex. Both of these goals were successfully met. The researchers managed to catch X-ray flares, or outbursts, from Sag A star during the EHT observations, a faint one seen with Chandra and Swift, and a moderately bright one seen with Chandra and NuSTAR. Astronomers have seen X-ray flares with a similar brightness to the latter with Chandra, but this is the first time that the EHT simultaneously observed Sag A star. This offers an extraordinary opportunity to identify the responsible mechanism using actual images. Astronomers were also able to learn more about the wider and complex picture of accretion. One of the biggest ongoing questions surrounding black holes is exactly how they collect, ingest, or even expel material orbiting them at near light speed, in a process known as accretion. This process is fundamental to the formation and growth of planets, stars, and black holes of all sizes throughout the universe. Scientists will be able to use the data being released today to improve and hone their theoretical models of how black holes behave and interact with their surroundings. They will continue to study this unique combination to learn more about Sag A star and black holes throughout our universe.